Hi, today you're finishing up chapter 5 with section 3. Valence electrons. We talked about in the last chapter the electrons that were in the outermost shell of the atom, and that now has a name for it, and those are called valence electrons. Valence electrons are electrons that are located in the outermost energy level of an atom, so the very last shell. Elements in a particular group have similar properties because they have the same number of valence electrons. So if you have the same number of valence electrons, that is because you will end up being in the same group. Alkali metals. Alkali metals are in group 1, and you do need to know that group 1 is named alkali metals. You need to know that. They have one valence electron. Notice that it's the same as the group number. These are the most reactive group of metals, and they are so reactive that they are only found as compounds. I'll show you a video on that tomorrow, but they are very, very reactive. They actually have to be stored in oil, so in order for them to be found as, they're only found as compounds. So all of these are stored in oil because otherwise they would react with the air and become a compound. Alkaline earth metals, make sure you realize that it's alkaline, whereas in the first one was alkali without the Ne. This is group 2, so they have 2 valence electrons. They're harder metals than group 1 with higher melting points. So they are reactive, they're just not as reactive as your group 1 elements. And you've got, they all have 2 valence electrons, like I said. Then we've got the boron family, that is group 3, and it's called the boron family because the first one in it is boron. There's 3 valence electrons, and it contains metals and metalloids. So in this group, the one you're probably most common with is aluminum, because that's for aluminum foil or aluminum cans. Next we have the carbon family, that's group 4. It has 4 valence electrons, and it contains metals, metalloids, and nonmetals. This is a picture of a computer chip which has silicon in it, and it probably has germanium in it as well. Tin, they used to make cans out of tin, but they make them out of aluminum now. Carbon, that is in your pencil. Graphite is carbon. Nitrogen family, that's group 5, so it has 5 valence electrons. It contains metals, metalloids, and nonmetals. Nitrogen and phosphorus are very common in fertilizers. Arsenic is a poison. Bismuth is in Pepto-Bismol. Next we have oxygen family, which is group 6, so it has 6 valence electrons. It has metalloids and nonmetals. Oxygen is what we breathe. This yellow is a picture of sulfur. You might have smelled that last year. It smells like rotten eggs. Halogens is group 7, and it has 7 valence electrons, and it is the most reactive nonmetals. For this, we've got the first few are gases. So fluorine and chlorine are gases. Bromine is a liquid, and iodine is a solid. Iodine tends to be purplish in color, and that's like what they would rub on you before they cut you open in surgeries. Chlorine is what they put in pools. Fluorine, or the fluoride, is for your teeth. And these are all really, really smelly. And then last we have noble gases, which is group 8. It has 8 valence electrons, and these elements do not react with anything. And they are all colorless, odorless gases. We've got helium, which is in the blimp, and I'll show you a video about that tomorrow. Most people think of these as neon signs. They don't have to be neon signs. Neon is actually like the orangey color. Every single kind of gas, when you put an electric current through it, can emit color, and so it just depends on which gas you have. And that there's just a little bit more of notes, but that was just the main notes, and we'll talk about this tomorrow. So we talked about the main groups, so those all have names for it. In the middle, this group here, those are your transition metals. And then down here are your inner transition metals. So this is the lanthanides and this is the actinides, but these are the inner transition metals, and we will add that to your periodic table tomorrow. So the inner transition metals are on the bottom. That is it for today's notes.